Welcome to AI Podcast. I'm Daniel, and today we're unpacking an ICLR 2025 paper titled From Exploration to Mastery, Enabling LLMs to Master Tools via Self-Driven Interactions. The promise is practical. Let a model actually use a tool, learn from what goes right and wrong, and then rewrite the tool's documentation so the next attempt is better. Keep looping until the gains level off.
I'm Maya, so it's not just reading a manual and hoping for the best, it's more like the system edits the manual after each round of hands-on experience. That's the headline?
Exactly. The framework is called draft, which runs in 3 phases: explore, analyze, rewrite. 2 safeguards keep it efficient. 1 pushes the model to try diverse cases so it doesn't repeat itself. The other stops the loop when successive document versions stop meaningfully changing.
Nice. Before we dive deeper, who led the work?
It's led by Changle Q and colleagues across Renmin University of China, Baidu, and the Chinese Academy of Sciences. The paper was accepted as an oral at ICLR 2025, which signals strong interest from reviewers.
All right, what problem are they really solving here? I know tool-using models often stumble over parameters, error handling, or even which endpoint to call.
That's the pain point. Most API documentation is written for people, not models. It can be verbose in the wrong places, miss crucial constraints, or get out of date. Draft closes that gap by treating the documentation as a living interface. The system learns from its own tool calls, then rewrites the doc so the next round is clearer and more precise for the model.
So instead of only tuning the agent's behavior, they improve the interface the agent reads. How do they structure the loop?
First, the Explorer stage generates realistic use cases and actually calls the tool, logging results and errors. Second, the analyzer reads the current doc plus those traces and identifies what's missing, misleading, or redundant. Third, the rewriter produces a new version of the doc and suggests what to explore next. The diversity mechanism encourages varied scenarios, and the adaptive stop ends the process when 2 consecutive versions converge.
Got it? Where did they test this?
3 settings: a movie database API suite, a music streaming API suite, and a demanding public tool use benchmark. They evaluate across multiple models, including GPT-4o, the smaller GPT-4o Mini, and Llama 3 70B. The main metric is whether the model produces the correct sequence of tool calls for a task, and they also report a pairwise win rate against a strong baseline.
And did rewriting the docs actually help in practice?
Yes. Across all 3 datasets, draft refined documentation consistently improved accuracy over strong prompting baselines. To make it concrete but easy on the ears, here's one example. On the movie database tasks with GPT-4o, the correct path rate rose from the high 70s to about 88% once the docs were refined. The music tasks and the broader benchmark also showed clear gains.
That's encouraging. Did the improvements carry over to other models, or were they tailored to a single one?
They generalize. Documentation rewritten with GPT-4o's feedback also helped GPT-4o Mini and Llama 3 70B. The authors even show that using different backbone models for the rewriting still yields cross-model benefits, though GPT-4o performed best in their tests.
Do they analyze why iteration count matters?
They do. Performance tends to improve for a few rounds as the doc becomes sharper, then can dip if revisions become redundant. That's exactly why they add the tool adaptive termination rule.
Anything beyond raw task scores? I'm thinking about how teams find the right tool before calling it.
Good point. They also report better retrieval scores when picking tools from a catalog using standard retrievers. The takeaway is that the rewritten docs are clearer not only for the agent but also for upstream selection.
Let me push on limitations. What should practitioners keep in mind?
3 things. First, the main experiments rely on proprietary components, GPT-4o for rewriting and an OpenAI embedding model for the diversity check. If you swap in fully open components, accuracy and cost profiles may shift. Second, part of the evaluation uses a pairwise win rate against a baseline, which is practical but should be complemented with robust programmatic success checks for production use. Third, running iterative tool calls isn't free. You'll want cost caps, rate limit handling, and clear policies for exploring only within safe scopes.
Makes sense. If you were rolling this out in a product, how would you start?
Start with a small set of high-impact APIs, the ones causing the most agent failures. Run draft with strict budgets and a human in the loop to approve doc changes. Plug the revised docs into both your agent prompts and your tool retriever, then watch failure rates, latency, and cost per successful task. If things stabilize and improve, expand to the next batch.
And for research directions?
Try a fully open stack for the analyzer and rewriter to explore the cost-accuracy trade-offs. Add stronger blinded evaluations that don't rely on model judgments, and push beyond single-tool tasks into multi-tool, long-horizon workflows where the documentation needs to describe handoffs and state clearly.
I'd also add safety. As the Explorer probes live endpoints, you'll want guardrails around authentication scopes, rate limits, and any side effects, and log everything so audits are easy.
Absolutely. Big picture, the insight is simple and useful. Treat documentation as part of the system, not a static artifact. If your agent relies on tools, improving the interface it reads can be the fastest path to better outcomes.
That wraps it. This was AI Podcast. If you found this helpful, share it with someone who maintains API docs or builds tool-using agents. Thanks for listening.
Thanks for joining us. Until next time.